This is Mr. Smith. Thanks again for joining me for some chemistry. Today we're going to talk about how to write ionic formulas, specifically binary ionic compounds, so things that we have at home like sodium chloride. Where does that formula NaCl come from? And the quick answer is that it comes from the periodic table. The longer answer is what we're going to spend some time on. So back in the 1860s, Dmitri Mendeleev, who gets an element named after him, element 101, splits the periodic table, or I guess he organizes the periodic table according to a few chemical and physical properties. And one of the things that comes out of that is we split the periodic table into a couple unequal halves. And what we have here is what's known as the staircase. And off to the left of the staircase, all of these elements over here are called metals. And then up here, the other side of the staircase, not surprisingly, nonmetals. And so we have a bunch of metals doing kind of one set of things, not only chemically but also physically. And on the other side of the staircase, we have a bunch of nonmetals doing, again, pretty much the opposite of what the metals do chemically and physically. And we'll talk about those properties later in the year. But for now, all we really want to care about is that metals over here, they're all going to do kind of more or less the same thing. They're going to form cations. And so what is a cation? Well, a cation is a positive charge. A cation means that they have lost some electrons. So all of these metals over here are going to form cations. So what that means is a positive charge. The left-hand side is a cation. Those are our metals. What are the nonmetals doing? So we zoom in over here. These elements over here, they are not going to form positives, but instead they are going to form negatives. And let me write down what a negative is. Let me zoom back in. Sorry about that. Zoom in. They're going to form negative charges. And that's my negative. A little bit sloppy. Let me erase that and try again. Negative charges. And a negative charge, anion. So that's the vocab for that. So we have cations, we have anions. And in an ionic compound, it's those metals are going to react with these nonmetals to react. Now they're also going to do so in a pretty specific way. Let me work on that. Cations, positive. Great. And so we have a bunch of positives going to react with a bunch of negatives. And again, they're kind of split up by their staircase. But that doesn't give us a ton of information about the formula. So it is true that ionic compounds are going to have a metal, which is acts as our cation, and a nonmetal, which is going to act as our anion. This positive, this negative are going to be attracted to each other to form an ionic bond. And again, we'll talk about what an ionic bond is later in the year. But so that's a little bit closer to telling us how we're going to write these formulas. To go a little bit beyond that, let me erase that and move over to what I call a charged periodic table. Here we have the same periodic table, but now it's split up into charges. And again, Mendeleev put these together not knowing about electrons, not knowing about gaining and losing electrons, not knowing that metals give electrons and nonmetals take in electrons, because electrons weren't discovered for another 40 years. But in hindsight and a few years of study, we come up with this relatively color-coded periodic table. So not only do we have a bunch of metals on the left-hand side with positive charge, and nonmetals on the right-hand side with negative charges, we actually have specific numbers that go along with that. So not just positives, not just negatives, but specifically, the first column is going to be a +1 charge. The second column is going to be a +2 charge. This 13th column is going to be mostly a +3 charge, where I highlighted it in green. And then a few over, you have a -3, a -2, and a -1. Now, this is something you're going to have to kind of know and say quite a few times. 1, 2, 3, 3, 2, 1. And there's a big block in the middle that's positive, but they actually don't get a number assigned to it. In fact, all of the yellow, they're all positives, but they don't have a specific number of 1, 2, 3, 4, 5, 6, 7. They don't have a specific number associated with that, and we'll talk about that towards the back end of this talk. Now, I should mention there's a few elements without any charges. Hydrogen could be a +1 or a -1. Carbon does some weird things, typically does not form ions, and so I kept it unshaded. You have the noble gases that don't react with anything, especially ionically. Then you have some gray area here, and again, we can talk about that kind of later in the year, but what I do have color-coded is in the red, the orange, the green, the blue, the pink, the purple is something we can work with when doing ionic formulas, and we'll talk about the yellow as well. And so let me take a moment. So we're going to write formulas for these binary ionic compounds, and the first one I wanted to talk about is aluminum and sulfur. So aluminum is on the left-hand side as a metal, sulfur is on the right-hand side as a non-metal. Those two elements are going to come together to form an ionic compound. And so what is that formula going to be? Because it's not just going to be a random 1-to-1 ratio or always 1-to-1 or anything else random, 1-to-2, 2-to-1, 3-to-2. It's going to be something specific per ionic compound, because every time aluminum combines with sulfur, it's going to combine in a very specific numeric ratio that is repetitive throughout the Earth, planet, universe. And so it does follow a pattern, and it's that pattern we're going to talk about today. So here is aluminum on our chart, and here's sulfur on our chart. Again, aluminum's to the left of our staircase, sulfur's to the right of our staircase. Aluminum is going to have a +3 charge, and sulfur is going to have a 2- charge. And again, they're going to come together to form an ionic compound. Now, there's a couple different ways to think about this. Here is aluminum with a +3 charge. 3 little wedges there. Here's sulfur with a -2 charge. Now, they fit together. But again, they have to kind of match up. The unequal charges doesn't make any sense. The ionic compounds are going to have a neutral charge. Every positive is going to react with every negative. So right now we have too many positives and not enough negatives. So we're going to bring over another negative, like so. And that's good, but now we have kind of too many negatives. And so now when another aluminum comes over, and now aluminum is +3, you can't change that. And so I can only bring one whole aluminum over. And now, again, we're off balance. Now we have too many positives and not enough negatives. And so now I'm going to bring over another negative. And now it finally kind of works. Now we have 2 aluminums and 3 sulfur kind of wedges. So this kind of helps, and I hope it helps visualize for a moment that we need to have this equal charges. All the positives have to add up to all of the negatives. In this case, I have +6. In this case, I have -6. So overall, it's a neutral compound. And the wedges kind of all fit together, and now we have this compound. Now, we're not going to draw wedges when we do a lot of ionic compounds. We're going to do something called crisscrossing. And so that's over here. So here is my aluminum, and again, it has a +3 charge. Sulfur has a 2- charge. And so charges are superscripts, that goes up above. And what we're going to do is something called crisscross. So we have all these aluminums trying to become chemically neutral with all these sulfurs. So we need to crisscross that in a way that ratio works. And so you saw a hint of that here. I need 2 aluminums, 3 sulfur. So how do I get that from the charges? Well, crisscrossing means this superscript becomes this other subscript. So here's a superscript 3. And now it goes down to be a subscript 3, sulfur's subscript. This superscript 2 now becomes let me grab it correctly. This superscript 2 minus becomes a subscript 2 here. This is how many aluminums I need. So let's see if I can type it in correctly here. Aluminum, 2 aluminum. So this subscript 2 is down here. Then sulfur, subscript 3. So the 2 means there are 2 aluminums. So 3 means there's 3 sulfides, sulfurs, and we pronounce that sulfide, but we'll get to naming in a later video. So we have 2 aluminums and 3 sulfurs. Again, that 2-to-3 ratio comes from the charges. Notice that the charges don't go straight down, they crisscross over, they go diagonal. So one superscript becomes the other subscript. And now this is the formula for aluminum sulfide. And this is neutrally, this is electrostatically, this is electrically charged, neutrally charged, where every bit of positive is matched up with every bit of negative. And you can do this for quite a few others. And so we're going to do some examples here together. So here's the aluminum sulfur. I'll show you how to write it from scratch. Okay, so here's the aluminum. Here's the sulfur. So we put it in this box, 3 plus, sulfur, 2 minus, and then we crisscross. That goes down there. That goes down there. So Al2, S3. Notice we ignore the signs. Up top, they're charges. On the bottom, they are subscripts. There are how many aluminums, how many sulfurs. So I want to try a few more with you. Now you're going to have to go kind of bounce back and forth between the periodic table. So here's barium over here with a 2 plus charge, and here's chlorine over here with a 1 minus charge. So we get barium 2 plus, Cl 1 minus. Crisscross that, crisscross that. End up with barium 1, Cl 2. Now we go to the sodium and oxygen. Here's the sodium 1 plus, oxygen 2 minus. So we end up with sodium 1 plus, oxygen 2 minus. And then we crisscross that. O1, and this 2 goes down there, Na2. Strontium and bromine. Let's find strontium. Strontium's over here, 2 plus. Bromine's over here, 1 minus. So strontium 2 plus, bromine 1 minus. Crisscross that, Br2, crisscross that, strontium 1. Go ahead and try lithium and sulfur. All right, so we have lithium with a 1 plus, sulfur with a 2 minus. And so we crisscross that. We have 2 lithiums for every 1 sulfur. So now we go on to the next page. Now the 1s are not written since they are a bit implied. So sodium's in the first column, 1 plus. Chlorine is second to last column, 1 minus. So we can crisscross those 1s. Cl1, crisscross this 1, Na1, and again the 1s are not written because they are implied. So we get NaCl, good old sodium chloride table salts. Now one other little trick to it is having to reduce, because we don't need a 2-to-2 ratio. If you're exchanging 10s and 20s, it's a 2-to-1 ratio. You don't need 6 10s and 3 20s. It's still just a 2-to-1 ratio. So lead is one of the yellow elements with the unknown variable charge. And so you kind of need to be told what the charge is. And so you're told right here with a +4. And we'll talk about that later on as well. Now oxygen is a 2 minus. It's now what we end up with is Pb4 plus O2 minus. So we crisscross that, and we end up with O4. We crisscross this, we end up with Pb2. So that's good crisscrossing, but again, we don't need that 2-to-4 ratio. In fact, the rule is to have simplest whole number ratios. So this 2 and 4 can reduce. That 2 and 4 can reduce to bits. The 2 and the 4 can reduce down to a 1 and a 2. 2 is the common factor. 2 goes into 2 once, 2 goes into 4 twice, so it's 1 to 2. And again, we don't need to write down the 1s. And so, like so. Go ahead and try magnesium and oxygen. Find them on the periodic table and then try it out. So I do some of the work for you here. Mg2 plus, O2 minus. That crisscrosses to a 2 and a 2, and then that reduces to the 1 and a 1. Again, 2 is a common factor of 2, and so they reduce down to 1 and 1, and I don't have to write down the 1s. So I only need 1 magnesium to go with 1 oxygen. Just like $5 bills and $10 bills and $20 bills, 20s and 20s match up despite the fact that you need 1 20 with 2 10s. When you're exchanging 20s, they match up 1 to 1. So go ahead and practice a few of these, and little questions will pop up, and we'll go over the answers in a moment. So barium is a 2 plus, chlorine is a 1 minus, so we end up with barium Cl2. Strontium is a 2 plus, bromine is a 1 minus, so we end up with SrCl2. Cesium, first column, 1 plus, bromine, still 1 minus, so we end up with cesium bromide. Francium, first column, 1 plus. Sulfur is a 2 minus, so we crisscross that, Fr2s. And again, we don't have to write down the 1s. Magnesium is in the second column, 2 plus. Chlorine is 1 minus, second to last column. MgCl2. I'll go through these a little bit faster so you can keep practicing. Na1 plus, O2 minus, Na2O, and that's an A. Lithium 1 plus, sulfur 2 minus, Li2S. Calcium 2 plus, oxygen 2 minus. The 2's reduce and you end up with just CaO. Potassium 1 plus, sulfur 2 minus, K2S. Potassium 1 plus again, I1 minus, Ki. And the last thing I wanted to show you is what if you do have an element not with a charge on the periodic table. So you have the 1, 2, 3, but what about all of these yellow ones in the middle? They're all positively charged, but they don't know they're charged. So you need to be told, and you need to be told with Roman numerals. So iron, for example, could be +2 or +3. And it's not a matter of sometimes that iron is a 2 and cobalt's a 3 and nickel's a 1, and copper's a 2, zinc is a 2. Is some of these elements have different possibilities. So the first couple columns is always +1, always +2. The things in the middle, the elements in the middle have multiple possibilities. Sometimes it's 2, sometimes it's 3. So iron could be a 2 or a 3. So when you come up with an ionic compound, you need to be told what it is. So in this case, we have iron with a Roman numeral 2. And so that's how we talk numbers, is Roman numerals. So we end up with Fe2 plus, O2 minus. And then you just crisscross that like you would before. In this case, FeO, because we're reducing the 2 and the 2. Cobalt, right here, has a couple different charges, one of which is 2 plus. Chlorine is over here, which is a 1 minus. And so you crisscross that, and you get cobalt, CO, Cl2. Manganese has all kinds of different charges. It could be a +1, +2, +3, +4, +5, +6, +7. Manganese has a lot of different possibilities. In this specific problem, the Roman numeral tells you that it has a 3 plus charge. Fluorine is over here with a 1 minus charge. And so you crisscross that correctly, and you end up with MnF3. Last but not least, go ahead and try it. Copper, oxygen, copper 2 plus, oxygen 2 minus, crisscross, and then reduce, CuO. All right, so practice these. Thanks so much for your time. These ionic compounds are all around us, and we're starting to understand some of these chemical formulas. Remember, chemistry is everywhere.